going to take a look at logic now, and a few buzzwords or key terms in logic is the word Boolean. So if I write that down, Boolean, that really is a logical term. It's also a data type that you'll find in the majority of programming languages. I can't think of many that don't have Boolean, because logic really is in all programming languages. It's sort of the foundation of computers. It operates on true or false, ones and zeros, which is just binary, and that's how all computers are made at the present time. So you find it everywhere. So this is a data type. What we're going to look at today as well is something called Boolean algebra. Don't be frightened by the word algebra. I know that you've done it in maths and it involves letters and symbols, etc. There are a lot of algebras. The one that you work with in maths is just called algebra. This is Boolean algebra. There's, like I said, there's plenty more, but you will not meet them until maybe, I don't know, end of A level, start of degree level. So it's something that you can just look at and accept that this has got letters and operators, but they only work with Boolean values. Now, what are Boolean values? They tend to be true or false. I'm going to put them in capitals, it really doesn't matter. Python requires you to capitalize the first letter and the rest aren't. Other languages, that there's no case sensitivity, so it could be a lowercase t or a lowercase f. There's a problem with these two. Although they're very nice to play with and they actually do the job, it's a lot better if we just use 1 for true and 0 for false. That takes us into binary, and it really cuts down a lot of the confusion that you see on a piece of paper when dealing with Boolean logic. But for your information, either one will do. So you could use true or you could use false, 1 or a 0. Sometimes you can use yes or no. That is seen mainly in databases. So there's lots of ways of representing these. So what can we do in Boolean algebra or logic? Let's just call it logic. There are many sort of versions depending on the job that you're doing. If I was designing electronic components or electronic circuitry, I would want to be using diagrams, and there's only 3 that I'm really interested in. This one, which has 2 legs, they're inputs, and 1 leg coming out for an output, and then the symbol is like a D. It's got a straight back, and that is called the AND gate. And I'm going to write AND underneath it. Now, the words AND are used in programming. We can't represent a diagram in programming, we have to use the word AND. And that's available in every language. We've seen it in SQL, we've seen it in Python, how to use it. The second gate that I want to introduce to you is the OR gate. Now, the difference between the AND and the OR gate is that the OR gate has a curved base, still has 2 inputs, and it has a sort of pointed shape, more like a spaceship than anything else, and it has 1 output, and that is called the OR gate. So these are the diagrams at the top are for designing circuitry. They're useful for electrical engineers. These words are useful for programmers. The final one that we will look at is a triangle. You've got 1 input, 1 output, and there is a circle on the end of the triangle. And this is called the NOT gate. Sometimes they just call it an inverter, particularly in electronics, because it inverts whatever it's got. So if I put a 1 in, the output will be a 0. It inverts it, gives me the opposite. If I put a 0 in, it will give me a 1 on the output. So that is the electronic component version with the diagram, and the programming version with words. There is the Boolean algebra, so the mathematical symbols, you'll probably see this more in mathematics, but it's exactly the same thing. There is a symbol for AND, which is just, it's called a caret on a keyboard, C-A-R-E-T, not carrot as you would eat. It's just an angled bracket pointing up. Or is the opposite way round, so it's sort of a V. And finally, not is represented by sort of one corner of a rectangle in that direction. And that is the Boolean algebra symbols. This is the way that most things will be written down on a piece of paper or an exam paper. It will use these symbols, the and, the or, and the not. You will also see diagrams, just to see if you understand the logic, but in programming you would use these three words here. There are more symbols. We don't need to know them, and really you could make up anything from these three. You don't need to have the rest. They're just sort of combinations of. So that's the introduction. In the next video we'll start looking at truth tables.